This is Industrial PLC Applications. This video is on Network Communications Part 3, Communication Protocols. When we use the term Ethernet, what do we mean? At first it seems rather simple. It's a network. Well, in fact, it's one of many possible networks, and it has to share resources and data with other networks. Much like Windows as an operating system, and Mac and Linux and Ubuntu and Android/Chrome are all rivaling operating systems, they still have to find a way to share videos on TikTok. Ethernet is actually a platform of hardware and software that forms the backbone of many networks. It doesn't resemble its humble beginnings of a single bus line with all kinds of collision issues and dropouts. But that's only half the story, because so many different operating systems and hardware configurations are in play at any instance. There has to be some decorum, some method of standardization and commonality that lets every phone, computer, or PLC share data. So this brings us to Ethernet/IP. Well, this is actually read as Ethernet over IP, or Ethernet over Internet Protocol. So, what's a protocol? Well, it's an agreed upon standard and/or language of communication and actions. In this case, it's a standardization method of packaging and distributing information so that every machine so equipped can disseminate and use the data. Ethernet over IP conforms to an architecture of communications called the OSI, or Open System Interconnection Model. The OSI model is made up of layers, sort of like an onion, and as you peel back layers, you find another key aspect that makes everything work. Without diving deeply into this model, you're actually already familiar with parts of it without even knowing you are. The first layer is called the physical layer. That's the hardware you use to make it all work, like cables or Wi-Fi. See? Easy, right? The second layer deals with something we've already mentioned, MAC IDs. This is where things came from and the intended recipient of the data. In this case, we're talking about Ethernet since MAC IDs are Ethernet based. Okay, so far so good. Like we're 1/4 of the way up the top of the ladder. Okay. The third layer is a network layer. Think hubs, switches, routers, gateways. In other words, how the data gets shuffled around and arrive at the recipient. Here we are using Internet Protocol, so every packet of data will be wrapped and delivered in the same format, regardless of the end user operating system. But it's the fourth layer where things really get interesting. The transport layer is sort of like sending a package. Do you want it sent fast, or do you want it signed for? There are two main protocols used, UDP and TCP. Again, like any protocol, you have certain duties to perform. UDP stands for User Datagram Protocol. It is very fast and very reliable, but once you get in speed, you lose in guarantee. UDP blasts packets through, but the only assurance that the packet arrived intact is a checksum value. Not quite secure, since there's an infinite way to add up to a number like 2. The advantage is that even if the packet wasn't quite right, another one will be along almost instantly. Most PLC remote I/O and internet streaming is done via UDP. Transmission Control Protocol is the choice of transportation methods when accuracy is tantamount. It works differently and is more involved. Whereas UDP takes a newspaper and drops it off the porch, TCP rings the bell and asks for a signature. With TCP, a request is made to open a channel of communication, a socket. Once opened, the packets are sent in a particular order. Then, the sending unit waits for confirmation of receipt and that the data was received in the correct order with nothing dropped. Once this message is received, TCP then closes the socket again to avail it to another packet when ready to go. The The top three layers are lumped together: the application layer, the presentation layer, and the session layer. You're likely familiar with one or two of the protocols that are in play once the packet has been received on these layers. HTTP, well, that's Hypertext Transfer Protocol. And I know what you're thinking, hey, that's how web pages know how to display stuff. Well, not quite. That's HTML, Hypertext Markup Link, but HTML won't work without HTTP. FTP is File Transport Protocol, and if you've ever moved a lot of large data, you'll be using that transport. But here's one you likely haven't seen: CIP. CIP, or Common Industrial Protocol, is a protocol that was developed out of necessity. Prior to Ethernet and others, there are many forms of I/O in industrial communications like DeviceNet, ControlNet, Data Highway, etc. CIP codified the way that data would be packaged and expressed, either as implicit or explicit messaging and instruction. Today's CIP also includes motion control, safety, synchronization, diagnostic and system management information, and allows for integration of different systems through a common platform and protocol. Ethernet with a capital N over IP is not a spelling mistake. It means Ethernet over Industrial Protocol. It has the advantage of greater capacity to communicate with a larger amount of data. It is a protocol for carrying information from control and automation, which includes identification information about the device and the manufacturer, model, serial number, diagnostics, etc. It also allows it to communicate with other CIP devices over Ethernet.